Hello everybody. In this lesson, I am going to explain about the attacking species in organic chemistry. In the previous lesson, I have explained what are attacking species. Whenever the chemical reaction takes place, the reactants will be there. Those reactants, they combine together, they join together, they react together to give the product. Among the reactants, one we are going to call it as an attacking species. That is the species which initiate the reaction, which is going to attack the other reactant. That other reactant we are going to call it as a substrate. So here attacking species is the one which is going to create the polarity in the molecule, and it takes the chemical reaction to proceed. This is the one it going to initiate, it going to start the reaction. Those species we are going to call it as an attacking species. Generally they will be either ionic or they will be free radical in nature. So there are different types of attacking species are there. That is the one which going to attack the substrate to give the intermediate, in turn gives the product. So there are three different types of attacking species you come across generally in organic chemistry: electrophiles, nucleophiles and free radicals. All the three we will learn in detail. Reactant going to give the product. They are separated by an arrow mark pointing towards the products. The reactant may be same or reactant may be different. If the reactant are same and they are neutral, then the reaction doesn't take place. In order to take place the reaction, one has to initiate the reaction, one has to attack the other reagent. The reagent which going to attack initially, which going to attack first, that we are going to call it as an attacking species. Which going to get attacked, that we are going to call it as a substrate. So attacking reagent will going to attack the substrate, that in turn going to give the intermediate, that in turn going to give the products. So there are, depending upon the nature of the reactant that you are going to use, depending upon the nature of the reaction conditions, we are going to come across three different types of attacking reagent: electrophiles, nucleophiles and free radicals. Electrophiles, it's also called as electrophilic reagent. It is a Latin word which means electron loving. So they are electron deficient, that's why they're going to love the electrons. They're going to have the shortage of electrons. They are the deficient, electron deficient, therefore they're going to love electron. Therefore we are going to call them as electrophile. The reagent which can accept an electron pair in a reaction is called as an electrophile. They are electron deficient, they are positively charged or neutral. They may going to carry the positively charged, indicating that they are going to have a deficiency of electrons like H+, Cl+, Br+, I+, NO2+, CH3+, RNH2+, SO3H. But some of them are there. We are going to call it as Lewis acids, and those are the species, they do not carry the positive charge, but they are electron deficient. They are neutral electrophiles like AlCl3, BF3, SO3, FeCl3, RCOCl, RCHO, ketone, carbenes, nitrines, etc. Similarly, another class of attacking reagents are there. They are called as nucleophile. They are nucleus loving. So they are going to love the nucleus but not the electrons. The reagent which can donate a pair of electrons, they are called as nucleophiles. They are electron rich and they may be negatively charged or they may be neutral. Negatively charged means instantaneously we will see they are electron rich. They are going to have lone pair of two pairs of electron like Cl minus, Br minus, I minus, OH minus, Cn minus, RO minus, RCH2 minus, etc. But there are some neutral nucleophiles are there which going to act as a Lewis bases like ammonia, NH2, water. They are going to give the nucleophiles, no doubt, but they do not carry any charge. Such species we are going to call it as the nucleophiles or nucleophilic reagent. There is a major difference between the electrophiles and the nucleophile. These are the one. The attacking reagent is an electrophile, then the reaction path will be different, the reaction mechanism will be there, and the route of the reaction will be different, product will be the different, rate of the reaction will be different. If the nucleophiles, then the rate of the reaction and the path of the reaction, the mechanism will differ. Therefore, it is very important whether the attacking reagent is an electrophile or a nucleophile. So electrophiles are, as the name indicates, they are electron deficient species. Nucleophiles are electron rich species. New electrophiles accept an electron pair, they are going to act as a Lewis acid, whereas the nucleophiles, they donate the electron pair, they are going to act it as Lewis bases. The electrophiles attacks the electron rich atom, whereas the nucleophile will attack the deficient atom. As I already told you, depending upon the type of the attacking reagent, the path, the attacking will takes place in a different manner. Have an empty orbital which receives the electron pair from the nucleophile. They have an unpaired pair electron not holding too strongly to the atomic nucleus. Thereby, nucleus can easily give away the electron to accept that the electrophile should have the empty orbitals. Often cations, often anions. There are neutral nucleophiles or neutral electrophiles are there, but generally electrophiles means they are going to carry positive charge. We are going to call them as ions. And also another sort of attacking reagent that we have come across. This happens only in the case of the vapor phase and also in the case of molecules having the photolytic reactions. When we are doing the photochemical reaction, then only this type of attack takes place, and also in a vapor phase. These are the species, attacking species, which going to have an unpaired electron. They do not contain either a negative charge or a positive charge, but they are going to have odd electron pair in them. Such attacking species we are going to call it as free radical, but this happens only in the case of a vapor phase, and also when your reaction is taking place in the homolytic when it takes taking place in the photolytic action. Thank you. All the best.